Guys, welcome back to my YouTube channel. We're still under strength of material N5. So let's check the relationship between stress and strain. Uh, so as you have seen, relationship between stress and strain, we have learned about stress, right, and strain in material, but not how the direct relationship between them. To understand this relationship, you'll need to know what happens when a component is placed in a tensile machine. As you can see, when it's placed in a tensile machine and slowly stretch until it breaks, you will learn more about tensile testing in Module 2. That is Module 2. We'll talk about tensile testing. What I want to explain here is that, as you can see here, we have stress in y-axis, but then let me try and zoom out a little bit. But then you have a strain. You have a strain in x-axis. So as you can see, the relationship between, we're talking about the relationship between stress and strain. So let's say we have a metal. There is the metal. You pull this, you apply a force like this, a tensile, you pull it, the force that side. If you multiply your force there, and also I multiply, let's assume it's like this, and then you apply the force like that, apply the force in that direction. So here will be the start of the point, the run. Here is the rise, we are still under. Then here we'll have what, a limiting proportion. As you are pulling, we're applying a force that direction, we'll have the limit of proportion. Between this line here, you must understand that stress between these two, what you must understand that stress over strain. Remember, the stress over strain, you must know that Young's modulus is what is stress over strain is given by sort of like E, but is E like that. You see, this is they are not the same. As you can see that E, and then check this one. This is not one and the same thing. So yeah. So as you can see, between this point here, you must know this will stay constant. The Young modulus of elasticity, if you take the points there, Young modulus of elasticity will remain constant until you reach the limiting of proportion. Then the Young modulus of elasticity will start to change exactly at this point there. Will start to change them. As you go up gradually, you will change further. Then you'll reach the yield strength. Right? You'll reach the heat strength. Heat strength, that means it's when now you have applied mass force. You have applied mass force on this rod. Let's say it's a rod. As you are pulling, you'll reach the yield point. Will reach the yield point. Starting now, is strain here 10. You start as you're pulling, you're pulling, you'll reach to the ultimate. The ultimate is the final. It's when now you'll start, there'll be a neck that will forming on this. Let's see now, when you reach to that point, it's when you'll have your object will be like this. Now when you form, you'd see a neck developing. You'll see something like a neck developing there. You see, this is just one and the same. You see, there's a diameter that is reduced there. It's ultimate. So when there's a start of necking, there's ultimate. As you are keeping applying, you are still applying that force. As you are applying that force for the certain that of time, it's when as you're keeping, you keep, or let's say you keep increasing, you keep applying, increasing this force. As you keep increasing this force there, as you keep pulling, applying your tensile, as you keep pulling, you're pulling, you'll reach to the point that this neck will become actual will become more, will decrease much higher, will decrease much higher. As you go down, the neck will decrease. As you can see, the neck now will decrease because that graph shows decreasing. As you let's say for argument's sake, in this point there, you'll see that you'll see the neck reducing now. Will be small, 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 small. You'll see the neck reducing in size. That's when you'll start to see there will be a development. You'll see that now you'll see that your neck becomes small because it's decreasing. It becomes small, it becomes small, it becomes smaller and small. But when it reaches here, it's when you will break. It's when an object will break when you reach to that point, breaking strength. Now the strength of this material cannot bear your force no more. We call it's a fatigue. Now it reaches the stage of the fatigue where it does no longer able, the particles it does no longer able to withstand the strength that you have pulled in or the force that you have applied, so will tear apart. At that moment, it's when you'll experience will tear apart and cannot return to back to normal. So, but as you can see here at the limiting proportion, if you have a spring, I want to show you, let's say I have a spring like this. If you have a string and then the spring you pull it to that direction, within this limit of proportion, the spring, let's say you pull it, the spring will return back to its original length. Let's say you decide to pull the string, like you'll see something like this. But if you release the spring, will return back to its normal length, right? But as you come across the limiting of proportion, remember here the limiting of proportion, the spring cannot return back to its original form. There will be some deformation that will take place. So this is all about that actually. This study is all about this, to understand that this is all about that, nothing more. So far, that is what you're supposed to know. Typical stress graph, this is all about, So in argument, so still you see that the limiting of proportion, let me say the graph, remember there we had strain, here we had stress. So in other words, I can draw you see, until the limiting of proportion, there's a constant. You see this line is very constant. Let me just draw it like this. Is increasing sharply. That means the point there and there will be constant. If I take any point between the two, if I'm calculating Young's modulus, which is Young modulus, it is stress over strain. Any values that you will take between these two, if you take the stress in this line, and that you'll find that this will remain constant. Any values there, if you pick any coordinates or any strength there, you substitute, you'll find out this will remain constant until that the limiting proportion at this point, which is the limiting proportion, is when we have the proportionality. It's when we have a constant. It's when there is no change in Young's modulus of elasticity. That is what will occur. It's when your object, if you stretch the object, will return back to its original size, its original form. That is why for sometimes you find out you are playing with the spring, then you release the spring return back to its original form. You have not exceeded. That means you have not exceeded the limiting proportion. That is why the spring can return back to its It's a practical thing. That is why the spring returns to its original form. So have you not wondered again why sometimes when you apply the force, you have applied the force, pulling force, then suddenly when you release the spring does not return back to its original form. It's clearly indicating. So the scientists, they wanted to study what is going on, why I suddenly pulled this spring, or I started to pull this object and then does not return to its original form. But meanwhile, initially, as I have pulled this object but returned to its original form. What is going on? So this study, it was about to taking some tests to check what actually is going on. Going into details, to go into depth. Then they found out there's something which is called the limiting proportion. It's a limiting that there, if you exit that limiting, your object will start to defracture. It will started not even to diffraction, started to deformation. The deformation is when it won't return back to its normal form. Then there are things like we call it. It's when we'll see as it goes there, the yield point there, it's a yield. As you cross, they've come across things like ultimate tensile. It's when now you've reached the maximum stress to which material can resist load. As they've been examining, they said they've been experimenting, they found that they find out when the yield strength is the point where the test piece starts to get longer without making the load more actual. It's when you don't apply much strength. You don't apply much strength then goes you will have necking. Necking is the stage, the cross-sectional area of the test piece now, or of the spray. Any object that you're using now, reduce it, it's become most less. Then even the force that you apply, you'll find that the force, if you're applying the force now, it's just you no longer applying much force. It's all about that then in actual case. So yeah, guys, this is what you're supposed to know so far. Yes, for in this video will be just this introduction of this. Thank you for watching. Please do not forget to subscribe and click that notification button so that you'll be notified whenever I post some new video. Stay tuned. Stay tuned. So to show, okay, fine. To show, okay, stay tuned. No problem. All the best. Stay tuned. Then we'll see what we'll discuss about. We'll check Young's modulus of elasticity in detail in a second coming video. We'll check what is going on. Then we'll learn about the change in length, things like that.